This is lesson 50, BHDL example 30, and in this example we'll design a 4-bit adder subtractor using logic equations. You remember this was the adder subtractor that we designed in the previous lesson, where if we set E equal to 0, then this controlled inverter just lets B through and we have a 4-bit adder. Whereas if we let E equal 1, then this becomes a 4-bit subtractor. So let's see how we can write a VHDL program for this. A is an input 3 down to 0, B is an input 3 down to 0, E is in, and the carry flag and the overflow flag are out, and S is out 3 down to 0. So this is similar to what we had for our 4-bit adder. We'll set BX, which is a signal here, 3 down to 0, is going to be B exclusive ORed with E. Now note that we have to concatenate 4 E's together because B is a 3 down to 0, so we need to XOR it with a 3 down to 0, and this makes a 3 down to 0 E, in which each element is E. So then C0 just gets E. S is just A exclusive ORed with BX exclusive ORed with C, 3 down to 0. C is the carry, 4 down to 0. And then the CI plus 1 would be the C4 down to 1 gets A, 3 down to 0, ANDed with BX, or C3 down to 0 ANDed with A exclusive ORed with B. Just the logic equation we had for the carry out. And the carry flag is C4 and the overflow flag is C3 exclusive ORed with C4, just as with the 4-bit adder that we had. And here's a simulation to see if it works. So if E is 0, we're adding. So E is 0 here and 0 here, so we're adding A and B. B we set equal to B, or 11. So, for example, C is 12 plus 11 would be 23, which is 16 plus 7, so S is a 7 and the carry bit is set to 1, as would be expected. And if we're doing a subtraction, B is minus 5, so if we were to add, say, 2 to minus 5, then we would get, we're going to subtract rather, so we're going to take 2 minus a minus 5, well that's the same as 2 plus 5, so the answer is 7, which is of course the correct answer. Notice if we take 4 and we're going to subtract minus 5, so that would be 4 minus a minus 5, so the correct answer would be plus 9. Well, the 9 shows up here, but notice that the overflow flag is set, indicating that as a sign number it's the wrong answer, because as a sign number, you remember for a 4-bit number the values have to range between minus 8 and plus 7, and so plus 9 is outside that range. So the overflow bit gets set in the same way as it would for a full adder. So you can check the rest of this simulation and verify that in fact this adder subtractor works. You might also want to take this component and add the X7 seg B component, make a top level design as we did with the 4-bit adder, and you could download it to your FPGA board and maybe set the say button 0 to the E, and so then you would add or subtract the 4 bits from the switches depending upon whether you're pushing button 0. So if you push button 0 you could get a subtraction, and if you don't push button 0 you'd get an addition.